The topic of induction motors continue, and here we have an example that we have 208 volts, 10 horsepower, 4 pole Y connected induction motor, and it has a full load slip of 5%. Again, here we can see that slip is 0.05, that is actually equals to 5%. What is the synchronous speed of this motor? So for the synchronous speed, we know that the formula is 120 F electrical over P. And F electrical, let's see how much is the electrical frequency. It is 60 hertz. What are the number of poles? Yes, we have 4 pole machine. This is 4. So the synchronous speed of this motor will be is 1800 rpm. What is this speed? This is the speed of the rotating magnetic field inside the motor. Second part says, what is the rotor speed of this motor at the rated load? Rotor speed is actually the mechanical speed of the motor. The mechanical speed. So we know that the formula for mechanical speed, if we know the slip, we know that 1 minus S and synchronous. So the slip we know it is 0.05 and synchronous is RPM, 1800 RPM. So the mechanical speed will be then, it will become 1710 RPM. Now, what is the part C saying? What is the rotor frequency of this motor? What is the rotor frequency of this motor at the rated load? Rated load, and here also rated load. We know that the rotors, the conditions are given for the rotor rated conditions. We know that the electrical frequency, the frequency over the rotor is actually directly proportional to the electrical frequency, and where the slip matters. For S equals to 1, we know S equals to 1 is locked rotor, rotor is not rotating, and the electrical frequency, whatever is the electrical frequency, is actually the frequency over the rotor. And when it is S equals to 0, which is not possible in induction motors, this is actually synchronous motor condition, then there is no frequency, no voltages are induced over the rotor. So by this formula, slip we know that it is 0.05, electrical frequency is 60 hertz, and the frequency of the rotor will be 3 hertz. Okay, so now let's look at part D. What is saying in part D? What is the shaft torque of this motor at the rated load? So let's look at this motor. It's a rated load. We have 10 horsepower. This is the output power of the motor. This is the maximum output power the motor can deliver. It is, please remember, not the input power that the motor is consuming. Rated power over the nameplate is actually how much the motor can do the work. So for this condition, we know that the formula for a motor, P out equals to actually torque of the load into speed. Now this speed is omega. Remember, this is radians per second in this formula. So what it is asking is the maximum load, torque of load, then it will be P out over the speed. So the P out is actually 10 horsepower, but it is the unit of, we have to convert this into watts. So we will multiply by 76 watts. It will be converted into watts, and it will be less the mechanical speed we have calculated. It is 1710. And what we will do is we will convert this into radians per second, and we know how to convert this in radians per second is multiplying by 2 pi over 60. So the load torque will become, by calculating this, it will be to load equals to 41.7 Newton meters. So this is the maximum output torque that the motor will be producing. This is the shaft torque that will be produced by the motor. So that is how this will be solved. I hope it helps. Thank you.